Hey guys, hopefully you're getting a little more comfortable with geometric proofs now that we've had a few days to practice with them. We are going to do even more practice. We're going to add a few new pieces in here as we practice today. So, one thing you need to know is a new theorem. It's called the right angles congruence theorem. Pretty straightforward. All right angles are congruent to each other, which makes sense. Right angles are all 90 degrees, so they all should be congruent. Okay, so we just learned a new theorem, and now we're doing a proof. So probably we're going to see that theorem come up in this proof. So it says, write a proof given JK is perpendicular to KL, and ML is perpendicular to KL. So notice you can see that in the picture, those perpendicular segments. We need to prove that angle K is congruent to angle L. First thing I'm going to do is fill in the obvious information, the things that we should know. So JK is perpendicular to KL and ML is perpendicular to KL is our first statement. We know that our reason there is given. It's our given statement. We don't have to come up with a reason for it. Then I also know that my last line is going to be our prove statement. So angle K is congruent to angle L. So that's where I'm headed. Okay, so if I know that JK is perpendicular to KL, I should notice and see something here at that angle. And I notice that angle K is a right angle. And I'm using a little shorthand there. You can write it out if you want. And also from our given statement, ML is perpendicular to KL. Again, I see that right angle symbol, so I could say that angle L is a right angle. We know this because of definition of perpendicular lines. So then, if they're both right angles, then they're congruent to each other. And our reason to get from 2 to 3 then is our new theorem, our right angle congruence theorem. And that's it for that proof. Okay, so another theorem here, the congruent supplements theorem. If two angles are supplementary to the same angle or to congruent angles, then they are congruent. So I think this will make a little more sense if you're looking at a picture. So down below it says, if angle 1 and angle 2 are supplementary, so if they add up to 180, and then angle 3 and angle 2 add up to 180, then angle 1 is congruent to angle 3. So we take angle 2 out of the picture entirely there. If you want a proof of that, page 125 has a great proof, an example 2. The congruent complements theorem is very similar. It says if two angles are complementary to the same angle or to congruent angles, then they are congruent. So same process here. Angle 4 and angle 5 add up to 90 degrees. And angle 6 and angle 5 add up to 90 degrees. Then we know that angle 4 is congruent to angle 6. We take angle 5 out of there. This proof is going to be assigned as homework. So, using that congruent supplements theorem or that proof is probably going to help you out on this proof that'll be on your homework. Okay, linear pair postulate. This is something I think we have used a lot, we just didn't have a name for it. So the linear pair postulate just tells you that if two angles form a linear pair, then they are supplementary. So angle 1 and angle 2 form a linear pair, angle 1 and angle 2 are supplementary, so the measure of angle 1 plus measure of angle 2 equals 180 degrees. All right, the vertical angles congruence theorem, this is another one we've talked about. Vertical angles are congruent. You want to see a proof of this? Page 126, example 3 has a great proof. So that tells you that angle 1 is congruent to angle 3, or that angle 2 is congruent to angle 4. Those are our vertical angles that are across from each other. Okay, I got another proof to practice. So, our first statement says angle 4 is a right angle. I notice right away that's my given statement. I'm going to write that in for number 1. Then I'm also going to take a minute and write on number 7, angle 2 and angle 4 are supplementary. Okay, so my reason to get to number 2 is definition of a right angle. So if I know that angle 4 is a right angle, I want to think, what does it mean when something's a right angle? Well, it just means that it measures 90 degrees. So by definition of right angle, I know that the measure of angle 4 equals 90 degrees. So then, why do we know that angle 2 is congruent to angle 4? And this one kind of looks like it's coming out of nowhere. We need to go and look at our picture. So if you look at our picture, you'll notice that 2 and 4 are across from each other. What kind of angles are across from each other? Should be vertical angles. So vertical angles congruence theorem is the new theorem that we just learned. Vertical angles congruence theorem tells us that those two angles that are across from each other are congruent. All right, then definition of congruent angles. Definition of congruent angles says that if we know that two angles are congruent, then we know their measures are equal to each other. So if I know that angle 2 is congruent to angle 4, then I know the measure of angle 2 is equal to the measure of angle 4. Okay, now why then can we say the measure of angle 2 is 90 degrees? Well, if you look at this statement right here, and this statement right here, notice we're taking out the measure of angle 4, and they're on the diagonal, so we're taking out the middle piece. So that's the transitive property of, and I need to go and look, I have an equal sign, so it's the property of equality. If I had a congruent symbol, I would use C there instead. Okay, so then if I know that the measure of angle 2 is 90 degrees, and I know the measure of angle 4 is 90 degrees, it's telling me my reason is the addition property of equality. So if I use those two statements, if I add up what I see on the left-hand side and what I see on the right-hand side, that should help us get to this last statement. So the measure of angle 2 plus the measure of angle 4, those are both on the left-hand side, equals 90 plus 90, or 180 degrees. Okay, so then why can we say that angle 2 and angle 4 are supplementary? Well, we know that supplementary just means that two angles add up to 180. So this is just the definition of supplementary angles. All right. So let's look at a couple more examples. So example 3 says if the measure of angle 2 is 63 degrees, find the measures of angle 1, angle 3, and angle 4. We're not doing a proof here. We're just going to write out the measure of angle 1, the measure of angle 3, and the measure of angle 4. So if I know that 2 is 63 degrees, well, I should instantly be able to tell angle 4 then. Angle 2 and angle 4 are vertical angles. So if angle 2 is 63, angle 4 should also be 63 degrees. Now, I also see that angle 1 and angle 3 are vertical angles, so they should be the same. So if I look back up at my picture, I have right here, angle 1 and angle 2 add up to 180. They're supplementary angles. They're a linear pair. So I can do 180 minus 63 to get that measure of angle 1, and I get 117 degrees. For measure of angle 3 then, it should also be 117 degrees. Alright, example 4 says write and solve an equation to find x. Use x to find the measure of angle FKG. So first let's worry about finding x. So I notice the information I'm given is this angle right here and this angle right here. And so I notice those angles are next to each other and they're not across from each other. So since they're next to each other, they form a linear pair. We know linear pairs are supplementary, so those two angles will add up to 180. So I'm going to take 4x minus 1 plus 113 and set it equal to 180. I'm going to combine like terms on the left-hand side, so I get 4x plus 112 equals 180. Then I'm going to subtract 112 from both sides. And I get 4x equals 68. If I divide that by 4, I get x equals 17. So it wanted us to find x. There's one answer that we need. But it also wants us to find the measure of angle FKG. So FKG has 4x minus 1 listed. So I'm going to do 4 times 17 minus 1. 4 times 17 minus 1 gives me 67 degrees. So there's my answer for that. Alright guys, that's all I got for today. So I will see you in class. As always, come see me if you have questions.